All right, we're starting just here on page 61 where we're technically finishing the end of the set on complex numbers. And today I called these imaginary numbers, which we're going to understand the difference between the two terms here shortly. But it means we're going to solve each of these for a letter I. Let's check out what we would do here. In order to solve this first one, x squared, couldn't I just minus 100 from both sides here and get that x squared equals negative 100? And then just like in class today, I can take the square root of both sides and get, what's the square root of 100? It's just 10. But the negative means I'm going to have an I, or imaginary, part of my answer. That's it, 10i. Next one, let's do the same thing. We just subtract 24 from both sides and get t squared equals negative 24. I solve this by square rooting both sides, and I break down the 24 into 6 and 4, or 2 and 2 and 2 and 3. A 2 comes out, an I comes out, a 6 stays in. So my final answer is 2i root 6. How'd you do? And by the way, we talked in class about how this is two imaginary roots with the plus or minus. Okay, the next one cannot be solved as easily as those other two. We're going to have to use the quadratic formula. So here's my A, here's my B, here's my C. So we go x equals negative b plus or minus square root b squared minus 4 times a times c all over 2a. That's going to give me a negative. So negative 6 is going to be positive 6 in the front over 2. And then at the back, we get 36. I'm grabbing my calculator to do 13 times 4. And that's giving us 52. And so simplifying that, what is 36 minus 52? That's a negative root 16. So my final answer here is going to be 3 plus or minus square root of negative 16 over 2, which we know that the square root of 16 is plus or minus 4i. So we can go ahead and put in the plus or minus 4i, and 4 divided by 2 gives me 2. So this answer right here is 2 imaginary roots, or 2 complex roots. We're going to learn about this word tomorrow. I didn't use that word today. 3 plus or minus 2i from right here. Okay, so pause the video, get me A, B, C on the next one, and see how you do. Okay, x equals negative b plus or minus square root b squared minus 4ac all over 2a. So I'm getting 4 minus 20. Seriously, did we do the same number? Square root of negative 16, which we know is 4i, just like right here. So 4i over 2 is going to simplify down to the same thing of 2i. 2 imaginary roots, 2 complex roots. Okay, so the top ones wanted a full solve, but this next section only wants the discriminant. And the discriminant from today's notes was just the part of the quadratic called b squared minus 4ac. So when you get a, b, and c on these, you're only plugging in to the b squared minus 4ac. And if we get a positive discriminant, or greater than 0, there's 2 real roots. If we get a discriminant equal to 0, there's 1 real root. And if you get something less than 0, there's no real roots. There's 2 imaginary roots. So based on our notes from today of the discriminant, we're just going to say if there are 2 roots, no real roots, etc. So here I go plugging in. B is -5, A is 1, and C is 7. So this is going to turn into 25 minus 28. That means I get -3 as my discriminant. If I have a negative discriminant, it's called no real roots or 2 imaginary roots. Here I go again. B squared minus 4AC. Plugging in, I get -5, 1, and 6. This is going to turn into 25 minus 24, which just gives me a discriminant of 1. A positive discriminant means 2 real roots. So right here, I'm referring to this. A positive discriminant means 2 real roots. A negative discriminant means no real roots. And a 0 discriminant means 1, if we happen to get that coming up. This is my A, this is my B, this is my C. Plugging in again, just to the B squared minus 4AC. I get that B is -5, A is 2, and C is 5. It's going to turn into 25 minus 40. That gives me a -15 discriminant. I know that that means no real roots. B squared minus 4 times A times C, 49 minus 8. My discriminant is 41. This means a positive discriminant, 2 real roots. B squared minus 4 times A times C is 49 minus 48. My discriminant is 1. A positive discriminant means 2 real roots. Are you seeing the most common one? Next is B squared minus 4 times A times C. It's 49 minus 56. 8 times 7, 56. So that's a negative. Who cares? If it's negative, it's going to be no real roots. Let me just double check that number. -7. So 49 minus 56 is -7. That means no real roots because our discriminant was less than 0. Our discriminant was negative. Okay, next one, B squared minus 4 times A times C. 49 minus 48 again. Seriously? Hang on. 4 times 2 times 6 is 8 times 6. Gosh, we keep getting the same answers. When I get a discriminant of 1 or a positive discriminant, it's 2 real roots. B squared minus 4 times A times C is 49. This time it's 8 times 6 is plus 48. 49 plus 48 is 97. It's another positive discriminant. That means 2 real roots. Last, B squared minus 4 times A times C is 36 minus 36 is a discriminant of 0, which means 1 real root. So this middle section only wanted you to calculate the discriminant and only determine the nature of the roots. That's it. How'd you do? Now the last one says solve the quadratics using the appropriate method. We know to try factoring first to see if it works. Yes, it does. And if factoring doesn't work, you can use the full formula or complete the square method. So 7 minus 5 is 2. Let's try switching this around. 35 minus 1. This is not looking factorable. So I'm going formula right now. By the way, how do I know that I'm doing the full thing here instead of just stopping at the discriminant? It's asking for us to solve. So 920 times, what is that, 140? Let's go 20 times 7, 140. So 9 minus 140. My discriminant is negative. And since 131 is a prime number, it's just done. This has two imaginary or complex roots because of that I, because of the square root of negative 131 from right here. Okay, next one. Let's try factoring. Yep, it's factorable. All right, last one of the homework. You could go formula. I would not complete the square on it because doing the B work on a 7, not pretty. I can't tell if it's factorable. Let's try it. No, I'm just going to go full formula. We don't got time for that. Okay, negative b plus or minus square root b squared minus 4 times a times c all over 2a. Negative times negative is going to be positive, so 24 times 5. I'm getting 120. Oh, it was factorable. Check this out. Square root of 169, which works. So check out my answers. Negative 7 plus or minus 13, because the square root of 169 is 13, means I have negative 7 plus 13 over 12, and negative 7 minus 13 over 12 as my two answers. So this is negative, that's 6/12 or 1/2 for the first answer. And this is negative 6/12. No, negative 20/12, sorry. Which reduces down to negative 5/3. Okay, let me double check that math. Negative 7 minus 13 is negative 20. 4 goes in 5 times, 4 goes in 3 times. There they are. So two real roots, 1/2 and negative 5/3. It means it was factorable. Wow. This one over here also had two real roots. How are you doing? Are you getting good at the factoring? Are you getting good at the formula? This is two real roots. And it was only this one that had two imaginaries using our new fancy letter I.